Hello everyone, welcome to the ISTAS 2020. I am Tasnim Shiraj from Jahangirnagar University, Dhaka, Bangladesh. My paper topic is tracking users' interest in Twitter. My co-authors are Mr. Mushfiq Anwar and Mr. Alamin Bhuya. My presentation covers the following section: introduction, related work, proposed methodology, experimental results, conclusion, and future work. Introduction. Twitter has achieved significant attention in the social networking and microblogging due to its tremendous exposure to allowing users to publish their views and thoughts and share interest online. Online social network services like Twitter has recently been highlighted as a means of understanding the implicit interest of users from the abundance of online information. Interest monitoring for a business company means that certain companies represent consumers whose preferences are closely compatible with their business. In our research work, we propose invest derivation by tracking the user microblogging, considering other decrees such as time, activeness of the user that affect Twitter users' interest. A novel framework to set the interest rate and rank the user using the proposed architecture. Related works. The earlier strategies of tracking user interest and intention are still focused on tweets. A potential system was developed using Who Likes What as a foundation by Bhattacharya in 2014. He also presented a method depending on social annotations to deduce the topics of interest in a given tweet. Sheguni proposed two completely new approaches, Frisk and Ascertain, in 2017. While the first one determines user interest from the direct implication of words in the tweets, the latter method focuses on the implicit dimensions of the words. The main drawback of these previous methods is the consideration of interest as a probability, deducing desirable of words or a branch of words, instead of providing the precise definition of interest. As a result, topic of interest of the identified users may not actively reveal about his or her personality. In order to understand our research, we have to get familiar with the following terms. Social network. A social network is nothing but a graph which has three components. U corresponds a set of social users, A indicates the social contacts among the users, and T represents the set of topics discussed by the users in their graph. Topic. A topic distribution that contains most representative words for the topic. Query input list is a set of query topics. Activity. Sharing tweets, retweeting, reacting, comments are known as activities in Twitter. Time interval. It's a sequence of points in the time. Topical interest score. For each social user U, we measure her topical interest score related to the given query Q using the equation follow, where C is the control parameter, H is the difference of time between the end time of the interval IK and tweet posting time. It is the number of tweets by user U about the given query Q. T subscript M is the maximum number of tweets about Q posted by any user at a time interval. Proposed methodology. Identifying the social user's interest on any social platform is not an easy task. For example, a Bangladeshi user has been using Twitter for a long period. The individual is essentially a professional scientist, and most of his tweets are inspired by science events. During the World Cup cricket, he tweeted, "Well played, Saqib." From this post, it can be easily assumed that he is interested about cricket. This can conflict about his usual topical interest. Again, if a user is not much active, for example, he posts tweets very often, then it is also not easy to find his topical interest. So several other parameters should be considered in finding the interest of a user. This section outlines the methodology consisting of mainly two steps. At first, the pre-processing of tweets is accomplished to remove the noise and then apply the Twitter LDA topic modeling in order to get the topic mentioned in each tweet. Next, we calculate users' degree of topical interest for a given query queue over a period and list the top-ranked social users with highest degree of topical interest. The workflow diagram of the proposed methodology is illustrated in Figure 1. At the first stage, we collected the data. At the second stage, we filtered the data. For the third stage, we used the topic modeling. At the fourth stage, we did our analysis. Experiments were performed using the Stanford Network Analysis Platform dataset. Data preprocessing. Twitter users sometimes post random spam or noisy tweets. It is important to remove noisy tweets from the databases because they can lead to incorrect conclusions. The pre-processing of the sample data is carried out as follows. Remove RT@user. The RT@user is used when the user is retweeting some other's tweet. For Twitter self-LDA, the RT should be removed so that the differences between Twitter self-LDA and Twitter LDA can be observed. Remove user ID's URL. Twitter has special rules regarding preserved symbols and links that could cause confusion in later analysis. As an example, there could be a user with the same username. Therefore, the user ID URLs should be removed and replaced with IDs because the name might be same but the user ID is always unique. Inferring user topical interest. Suppose there are k topics in the Twitter and a topic distribution represents each topic. Distribution over k topic represents that each user has or his topic interest U. Topic k is allocated to each tweet of user U based on the topic interest phi U. Here theta b is the word distribution. The distribution of background and topic words is donated by pi, which is common for all users. From our dataset word, topic distribution using Twitter LDA is given in the table 1. The table obviously represents the topic of words of Twitter LDA. The topic 0 corresponds to Iran election with the words Iran, democracy, community, state and people. Death of the Michael Jackson correlates with the topic 1. Topic 2 is related to social media, while the topic 3 is better related with smartphone. Experimental result. In our experimental result, we have observed two different things. The first one is variation of topics with respect to time. The distribution of topics of tweets of a particular user over some time interval is shown in figure 3. The duration has been divided into 5 intervals. Obviously, during the first time interval, the user posted 3 tweets on topic 1. During the same period, he also tweeted about topic 2, 3, 5, 8 and 10. Again, if we consider the time interval June 22 to 26, he tweeted on topic 1 only one time. So, the user interest is not consistent. It changes over different parameters. And the second experiment result we conducted by ranking of users according to the rate of interest. We have taken users and their tweets from June 15 to 18 and the observation is furnished in the following table 2. The ID 1108 is ranked 1 with 7 number of tweets. From the table, we can see that if any user tweets more than one time, then all the values will be summed up and finally they will be divided by the maximum number of tweets TM about the topic K. Here we can see that ID 762 and 2900 have the same number of tweets, but due to the time difference we get different interest rate for both the user. We also ranked the user according to the topical interest score. We assumed 1 as the highest rank. Finally, in conclusion, we can say that we proposed two approaches to infer the user interest. We used the Twitter LDA model and proposed an expression for measuring the topical interest score of the users. The Twitter LDA model provided the most meaningful topic of the user interest. We believe that the employment and implication of improved Twitter LDA would be more effective way of finding user interest. We wish to perform investigation with other ways of inferring and tracking user interest in near future. Your time to interview me. What questions would you like to ask me? Thank you everyone. Thanks for giving me this opportunity.